Yeah, I'm good? Oh, that's better. I have two questions for you guys before we start. The first one is, who doesn't know what ORM is? Oh, that's great. And the second question, I've been listening for many talks today, and I decided that I have to, but I want to ask you, do I really have to say something about Trump, or we can just jump to the discussion about this design pattern? Okay. So it's going to take about 35 minutes, and then we'll probably have questions, maybe even less. The structure of the talk will be like that. First of all, I'll explain you what the problem with data is in the software, in writing software, why the data should not be visible, and why, what was the problem for many years with the visible data. Then I will explain how I think object-oriented programming is trying to solve that problem and why objects were invented. The next step is I'll show you how Hibernate, JPA, and many other ORM solutions are actually making it wrong, again bringing us back to the original problem. And then I'll show you the alternatives of how I think it should be done instead of using JPA, Hibernate, and all other ORM solutions. By the way, the question is, how many Java programmers are here? And others are, what languages do you use? .NET, Ruby, anyone? Okay. Well, I'm a Java developer, so I'll focus on Java, but in .NET and C#, there are similar technologies exist, the similar approaches, so you can probably be able to translate. There's not going to be a lot of Java code, you will understand it. And I hope you really use Hibernate or JPA or similar ORMs, and I hope you like them, because I will tell you that they're wrong, so we'll have some kind of a conflict, which will be hopefully interesting. Let's start with C, actually, not even Java, but take a look at this code. On the top, you see the structure. It's a data structure with just two data attributes, which is a point in some space. There are two attributes, X and Y, and there are two functions which are managing this piece of data. The first one is move_to, which is supposed to move, to change the coordinates of this point. And the second one is draw, which is supposed to put this point into some canvas to actually draw it in a black color. This is how it was. This is how it was for many years. The data are visible. The data are exposed, the data are public, and anyone can see that data and can manipulate the data. So both these two functions, they use this structure, they use this point, they use X and Y the way they want it to use. So the semantic of this data doesn't stay together with the data, instead it's spread over the code which is using the data. And the code we have here makes, because the data is public, is available and exposed, the code makes a lot of assumptions about the data. For example, if you look at the method draw, then this function, it's not a method, this function made an assumption that the point has to be black. When the author of this, when the developer who was writing this code, this person didn't know what the color is supposed to be. The person just found the X and Y coordinates and then made an assumption that the color, let's say, make it black. And there are many assumptions like that. In the first function, there are also some assumptions that the coordinates have to be 640 and 480, so there's some coordinate space. So the developer of that method, of that function, made another assumption. And all of these assumptions will be made eventually, if we develop like that, we'll have more and more functions like that, and in all of them, some assumptions about the data will be made. And what it will lead to coupling between these functions, between the code and the data. And this coupling, you know what coupling is probably, right? So there's the connection between them, and the coupling is quite tight, but it's not visible. It's not visible for the data itself. So if you look tomorrow at the structure, at the point on the first structure, you will not know how many other places in your code actually made that assumption about the black color. So there will be many places where this black is used because different developers, or maybe the same developer, they made that assumption, they made their code coupled with the data, but you don't know where it happened. And this is the bigger problem, because the coupling is tight, but it's not visible. For example, let's say tomorrow I put another attribute to the structure. And I say I have now the color over here, the color, and I have the scale. The color is right there, but I don't know how many places I have to find in the code in order to replace the black with the color from the structure. Because I can't find all of these connections. I can't find all the dependencies between the code and the data. And what it leads to, first of all, it leads to, like I'm saying, the code will be everywhere. We don't know where the changes needs to be made. It will lead to code duplication as well. Because in many places around the data, we will make many times that kind of assumptions, and we will inevitably duplicate ourselves. In one place, we make this check, for example, like on the left. In another place, we'll make another check as well. So the data, because the data are so passive and the data is so open and passive at the same time. They're basically like there's no active element there, just the data. Because of that, we will have this code duplication. We will have a lot of complexity as well. So all this code which is managing this data, the code will be quite complex. The complexity will grow with the amount of code show up. So the data stays here and the functionality grows around it and the complexity will go up. That's going to be a problem. And also the verbosity. So the size of code will be bigger and bigger also because of that. Because data is so small, they're in the center of the picture, and the code grows around it, duplicating itself and growing in size. It will affect, first of all, and it will affect maintainability. Maintainability is going to be the key problem, which will be very difficult to solve. It's basically will not be solvable. The idea of this controlling the data, I mean, the idea of the concept of data being in the center and the code manipulating with the data, I would call it command and control. So the code controls the data manipulates with the data, and the data is a passive component. The data structure doesn't know what's going on. The semantic is not in the hands of the data, but it's on the side of the code. And that's why it's command and control. Object-oriented programming offered a different approach. Objects, they show up with the idea to replace the command and control with a different paradigm, which I would call trust and delegate. So an object is a different thing from data. An object is an active element which encapsulates everything inside and doesn't allow anyone to couple with that data. So nobody can know anymore what is the structure inside that point in the space, inside that pixel. Nobody can couple, no piece of code can couple itself with the X and Y and make some assumptions about that. Because we encapsulate everything and we expose the behavior. We only expose the behavior, not the data. So data is not visible anymore, only the behavior which we expose. And that's how we come to trust and delegate, because we start to trust our objects, and then when something needs to happen, we just go to the object and say, do it for me. We don't take the data out of the object and then manipulate with the data like we did before. Instead, we trust an object and say, whatever you want to do, just do it. We don't care what kind of data you have inside. Do you have X and Y? Do you have color? Do you have scale? It doesn't really matter. We trust you. And with that approach, we solve all the previous problems we had before. This is how the good code would look in, let's say, Java. So we encapsulate X and Y. We put these two methods in this time, move to and draw, make them publicly available. We don't allow anyone to get X and Y from us. If they want to move this pixel, this point in space, they just come and they tell us what to do. They come and call the move to method. If they want to draw it on the canvas, they come and call the draw method. But they never can get the data out and then make some assumptions about the data and rely on that data. It's not going to happen. So we technically, by encapsulating the data, we technically do not allow anyone to do that. We don't allow them to make assumptions and couple and then make this coupling hidden. And this is called encapsulation. So there are many advantages of encapsulation. So first of all, like I said, there's no assumptions anymore. They will not be made. The second one is not command and control anymore. It's trust and delegate, because they don't take out anything out of us. They just trust our methods and they call that methods. There's going to be no random places which we don't know about, which manipulate with the data from us. And because of all this, the maintainability will go like higher. It will be easier to maintain. We will always know where the code is. We will always know that the code stays together with the data. And if something changes, if we introduce the color attribute, for example, tomorrow, we know exactly where to find the code. We know exactly where to find the methods which need to be improved, which need to be fixed in order to take this new attribute into account. That's how it looks in an ideal world, in an ideal object-oriented concept. But the reality is different. The reality looks like this in Java. This is what, in most cases, we have when we talk about objects and classes. We don't have the code I showed you before. We have the code, we have this one code. So we encapsulate, it looks like we encapsulate X and Y. We call them private. And then we introduce getters and setters, which, you know what getters and setters are. We still allow the code which stays outside of our object to get the data out and to put the data back. So this is what many Java libraries are full of, this code. It looks like object-oriented programming because the name is class, the class is here, there are methods, there are private attributes, but in reality it's exactly the same code we had before in C. It does exactly the same. It allows to do the same because it allows these getters and setters. They allow these static methods or whoever it is, other objects, to couple with us, to rely on this data, to know about the data, and make these assumptions and couple with us. They will use getters and setters to retrieve X and Y, to manipulate with X and Y, to use them somehow, and then we see again, you see this black, the name of the color. Again, it escaped the object, it stays somewhere in some utility class, we don't know where it is. When we introduce the attribute color in this class point, we're not going to know where exactly we need to find the place to fix it, to change the code so that this code will know about the new attribute. So what we have here is Java, is kind of object-oriented programming, but in reality, it moves us back to the original problem. So exposing this data out, letting the data escape the object, brings us back to C code and brings us back to the original problem. So the code becomes unmaintainable. So probably most of you understand where I'm getting at, because now I'm gonna talk about that stuff, about Hibernate and how they use objects. And if you use them frequently, the previous slide should look familiar to you because this concept of an object with getters and setters is one of the things they have there. If not, let's look at the example. I'll show you how it works in Hibernate. This is, let's say, and now now we're not going to talk about databases. Now we want to put this object, this point, into the database, into the persistence layer. So we want to persist it somewhere. We want to keep it in the database so that when we shut down the system, we start it again, it gets back from the database, and we know where that pixel was located. We want that point, we want that object to know, somehow we want to save it to the database, and then somehow later we want to be able to retrieve it back. So how we do it in Hibernate, how we do it in JPA in Java. So first of all, we create this class which is called an entity. So we annotate it. These annotations inform Hibernate what's going on. We have these two getters, two setters, and also the getter for the ID, so we can find that thing in the database. And now the code, it's kind of this is the most complex piece of code here, so don't really try to read it through. But the idea is that first of all we start a transaction, then we create a query, SQL query, kind of SQL. Then we inject the parameters so we know what's the ID of that point. We retrieve that point, then we retrieve that point, which is actually not like the object which encapsulates everything, but a so-called data transfer object. So it's an object with setters and getters, which is very close to that data structure we had in C. So it comes back from the Hibernate engine with the data injected. Then we manipulate with that data and bring it back to Hibernate, saying, and now save it back to the database. And we close the transaction. So the way it looks more graphically would be like that. This is our code on top. So this is what I just did. I just took a piece of it. So we have two basically points of control. But three actually. The main one on top, which is doing command and control thing again, because it controls these two elements which kind of report to it. So this is the guy on top is in charge. On the left, we see the point, the class point, an object of class point with two setters and set x, set y, and also two getters, get x, get y. And on the right, we have a big engine which is coming from Hibernate, which knows how to save that object to the database. So first of all, we talk to two points of contact. We do command and control. So we tell one point, we ask Hibernate, give us this data structure, then we'll manipulate with the data structure, then we put it back. So what we have on top is exactly the piece of code which now makes a lot of assumptions about our structure of the database, which knows what's going on, and we have exactly the same problem like we had before with this black color attribute. So if something changes in the structure of the database, that code has to be changed. But we don't know how many more pieces of that code we have everywhere. We can't find them because there will be many clients. I would call it a client who's actually, who's working with us. There will be many more clients like that, which all will contact the Hibernate engine, and they will communicate with our object. But if something changes with an object, if we change the structure of the database, for example, then we will need to, somehow find all the places which are working with that object. So on a high level, it will look like this. The object point is on the left, the Hibernate session on the right, the JDBC is inside. JDBC is a Java library which actually makes database connections. So the session from Hibernate, the session kind of encapsulates JDBC, so we don't know how it works with the JDBC. It's inside, which is good. So we just talk to the session, we just interact with the Hibernate, and we interact with our object. So the client is in charge of putting these pieces together. Like I said, there will be many problems with that. The maintainability, first of all, will suffer. So this ORM approach seriously affects maintainability. Because the code which we have with the client, like in the previous example in C, it will be everywhere. We'll have many places where this code, which knows about SQL, which knows about structure of the database, it will be duplicated, it will be bigger, it will grow, it will be complex, it will be out of our control. The object on the left will know nothing about this code. If you look at the object point, it will look like this. Let me scroll a few slides back. It will look like this forever. It's a simple class which will not going to grow. It will stay like that. And the code around this class will grow and grow and grow. You will have many places which know how to manipulate with this data. It's exactly what we had in C 40 years ago. It's exactly what object-oriented programming was supposed to solve, and solved by introducing objects. And then Hibernate put us back by suggesting to use that so-called data transfer objects. It's just primitive objects which are not really objects, but they're supposed to transfer data. That's the idea, that's the design, which actually not making the code better, but even only worse. So what is the solution? The solution is get back to encapsulation. That's what I'm proposing. And not just me. You can Google on the internet, or you can Google for it, you can find it. Many people are saying the same, that ORM, in the way I just explained, is the bad idea, because it's not object-oriented idea. It's not, we are losing the concept of objects. We're losing all the advantages object-oriented programming gave us years ago. We're just jumping back to procedural programming. You also say again? Yeah, as well. Yeah, that's right. Well, that's a secondary point, but that's a good point. Of course, my primary point, I'm focused now on object-oriented and not object-oriented. But that's a good point. You also lose a lot of advantages of the database. You lose the power of the database because the majority of because the functionality because basically you let these you let this engine manipulate with the data. And all they can do, it's a quite limited amount of things. This engine, no matter how powerful it is, it's still a limited amount of functionality they can do just looking at your data transfer object and understanding how to get the data from here and put it in the database. Somehow it will be done, of course, but because you're not in charge, because the object point doesn't know anything about the database. This object doesn't know whether it's MySQL or Postgres. The object doesn't know whether it's SQL even or no SQL. The object doesn't know anything. It just holds data like a data structure, and then somebody comes in, takes the data and then in some universal generic way puts that data into the database. So that's a good point, that you cannot, in this way, you cannot control what's going on because somebody else, the client, is in control and that thing. So what's the alternative? This is the alternative. Encapsulate. So put this stuff into the object. That's all I'm saying. So we need to make sure that the object encapsulates everything, including the way it persists itself, including the way it saves itself to the database and retrieves it back from the database. And that's how the picture will look. So the client, I'll show you the code now, I'll show you Java code. So the client will contact our point and say, move to left, move to right, whatever. And the point will know what the adapter is, I mean, how to talk to the database, and then this adapter will talk to JDBC, and we don't care what's going to happen. All we care on the client side is that we talk to the object, and all we talk to is that object, not somebody else. In that case, we have the trust and delegate again. We trust the object. We trust that as long as I talk to you, if you're an object, then you will take care of everything else. I don't need to command and control you. I don't need to get your data out of you, do something with it, go to Hibernate, inject it to the database, and always stay in charge. No, I just talk to you and say, do what you have to do, and it will happen. So it's trust and delegate. I trust my object in this case. And it's encapsulation. So we encapsulate, encapsulate, encapsulate. That's what objects were for. And this is what the code will look like. More or less like this. Take on the left, look on the left. This is how the client will look. We create a new instance of a point. We give it the ID, for example, 1, 2, 3. This is the ID in the database. And then we provide the dependency, which is DB. So we just inform that object, where is the database, what to encapsulate. And then we say move to the different coordinates. And that's it. So the client now doesn't know anything about persistence layer. He doesn't know how it's going to happen. He doesn't need to make any assumptions about that. He doesn't need to write any SQL. Everything happens later in the object, and the object does, here I'm using this Juke library, which is quite popular, but there are many other libraries. So the Juke actually helps us to write SQL, to format the SQL query, and then it goes to JDBC, then it goes to Postgres. It doesn't matter. So what happens in the object happens in the object. What matters now is that the client and the object, they're perfectly decoupled now. So if something happens in the object, if I want to change the structure of my database, I just go and change the structure. And then I look at the one single object, and this is one single place where I need to make some changes. I don't need to go around all my clients and see how they're actually using my primitive simple object. Not at all. My object is big. It's way bigger than before. So in the Hibernate case, it's quite simple. It's really small. It's data transfer objects, 2, 3 getters, and that's it. It's that size. In this case, it's way bigger, but it encapsulates everything. And that's the point, and that's important for maintainability. This is how the code will look like, I guess. It's not a real Java code because I don't really know how it's going to happen inside. What's important here is that the class will encapsulate the database, so it will know how to talk to this persistence layer, and it will know the ID of this element in the database. And then the code, let's say, move to. So what will happen? It will say this.db update table point set x, y to something. It doesn't really matter for me here, like how it will happen in this object, how it will actually calculate, and how it will communicate with the database to change the data in some specific table in the database. Because everything is encapsulated, and as a client, I don't worry anymore about internals. So that's I think a solution. That's how it should be. And now one of the last slides. So my question is, why did it happen? Like, why we had the problem, and then we had objects, and then people who were trying to integrate Java with the relational databases, they somehow introduced something which is anti-object-oriented. It's not object-oriented. It's back to the to the primitive way of managing data with the command and control paradigm. Why did it happen? And I think it happened because the very idea of mapping relational data to object-oriented world is wrong. So there should be no mapping, because these things like records and relational tables and cells, they are in a data world. But object-oriented world is behavior-driven. It's not data-driven. So we should not have a one-to-one mapping from table to object, from table to object. This is what Hibernate is suggesting. This is what ORM is suggesting. So if you have a table in the database and the table is called users, then you have an object in Java which is called users. If you have a table which is called transaction or payment, then you have an object in Java which is called payment. But this is wrong. It shouldn't happen like that. Because in the Java, we need to think in objects. We need to think user and payment and car, I don't know what it is, like book, whatever. Money, payment, all the things, all the entities which are coming from the real world, from the world you're modeling, like you're designing. And then you think and then you have a database, relational database. So let's say you have 3 or 5 objects here, and then 15 tables in a database. And then you do the mapping. You start to design an object called car. And in the database, you have 3 tables to represent the car, which needs to be joined, for example, in order to really represent the car. So how they are managed, how we join them, how we then put them together, and how we map our object world to relational world is done through SQL queries. That's what the language is for, this SQL language. But the way people introduced it a long time ago with this Hibernate approach, they just looked at the relational world and looked at Java world and mapped it one-to-one. And this is what the problem started from, because there should be no mapping. We should not map relational data to objects in Java or in any other language, which is object-oriented language. Because of this mapping, I think the mistake happened. Because, well, if you want to map one-to-one, then you will inevitably you will think that if we have the table called users, and then we have a name, and we have an age, and we have a salary, then we need to have exactly the same attributes here. And then when you have attributes, of course, you will make getters and setters to make that attributes available. And then you stop thinking about objects, you just start thinking about data. Then you map that data to data, and then, of course, you end up in the data world. But you have to be in behavior world, in functionality world, in object world, not in data world. So this mapping of the data world to behavior world, what was the cause of the problem? I think so. And there are a number of libraries. I'm not suggesting to use, well, there's one of them is my library on the right down, but this Juke library is way bigger. And there are many other libraries you can find on the market, which will help you to generate your SQL queries and retrieve data from database and put it back in a really convenient way. As convenient, maybe sometimes even more convenient, maybe sometimes even less convenient than Hibernate. For small applications, for really small, when you have a few tables in a database, the Hibernate will work definitely better, I think so. Well, faster, because you just put a number of classes, so-called, these DTOs, these data transfer objects. You will just design a few of them, you will just immediately map them to the database, and boom, it will start working. But on the long term, if you think about maintainability, if you think about the future, then work with these libraries. Encapsulate your interaction with the database. Don't use ORM. That's what I wanted to say. I have a book about object-oriented programming. It's a little bit of promotion now. I have a book about object-oriented programming. I'm writing right now the 2nd volume, and it's going to be the whole chapter dedicated to ORM, explaining the same thing again, explaining why ORM is wrong. So if you're interested, Google it. You will find probably Then in the first volume, there was a lot of discussions about why objects are actually better than structures, than data structures, and what's the point of going from procedural programming, from data-driven development, to actually object-driven development and behavior-driven development. That's in the first volume. The second one will discuss ORM as well. So that's what I wanted to say. Thank you very much. If you have questions, let me know your opinion about all this. Did I touch the nerve? Did I say something new? Yeah, go ahead. What about functional? What about functional programming? That's the question. Well, functional programming is a good thing, definitely. But I think functional programming and object-oriented programming, they're actually solving the same problem, but in different ways. So the original problem, which I explained in C language and older languages like COBOL, assembly, whatever, they were data-driven, and data were always, the main thing, and the code was in control of that data. It was not good for maintainability reasons, because it was really difficult to maintain that kind of code. If you look at the big C libraries written in C, it's really difficult to actually put things together because like I said, the code is everywhere, and then the data is here, and you don't know where actually is the code, where do I need to change, what's the next place to change. So functional programming make a step forward and said, okay, let's introduce something which will help us to encapsulate. Let's introduce functions, which will help us to group things together, and then make sure that if it's grouped here, it's nowhere else. The same is with objects. If we group things together and we call it an object, then we know that it's here. It's here is nowhere else. So we know that if we touch something, we just need to touch one place. So it's really good for maintainability. So functional programming is one direction. Well, I mean, it's the same direction. They just improve maintainability. I think so. I write sometimes code in function. I mean, in Clojure, for example, or Lisp, and I like that. But I think object-oriented programming is a little bit more powerful than functional programming, even though now functional is becoming popular, more popular than object-oriented. But I should say, my opinion is that object-oriented programming is more powerful because, first of all, because it better resembles, it looks closer to the real world. If you look around, you see objects. You don't see functions. So functional programming, you need to think in functions. You need to think in function composition, which is something is good for really, hardcore programmers, but not, people who are just coming from the real world and becoming programmers, or just people who, who like to think in things they see. So object-oriented programming is more powerful. I think so. No, it's clear, it's easier to understand, and more powerful because an object has a state, while a function doesn't have a state. So function only does something for you, but you can't ask a function, what's your state right now? Who are you? You can't ask that question to a function. Function just makes a result for you. An object also gives you results, but you can also ask an object, who are you? So this encapsulation of attributes is what makes objects more powerful than functions. Aside from that, they're really close concepts. A function in Lisp, for example, an object in Java. That's what yeah.
What's your take on the repository pattern? It tries to model databases as objects.
Yeah, it's a good question. I made a slide for it. So, yeah, I was kind of prepared to a number of questions. So it's called active record or repository. It's like kind of close. So the pattern is, probably you know what it is. It's kind of similar to ORM, but a little bit different. So in case of active record, we still have this functionality, this Hibernate, this engine, which stays somewhere. But in case of in the example, like in the case I explained before, we have this object and the engine. They stay like that. In case of active record, they put this engine, which does everything with the database, into the parent class. So now you look at the point extends some active record. And then when it's time to save that data to the database, then it's called this update. So from the client point of view, now it looks like we just call move to, and we don't see the database. It looks like this. It looks like we don't see the database. Because you see, it kind of encapsulates everything. But in reality, what I think about this pattern is that it even makes the code worse than ORM. Because still the object is not in control. Still the object doesn't write the SQL. still the object relies on some engine, which is in the pattern, in the parent class, that the parent class will come back, and that's why I made them protected. So the parent class will come back and get that data attributes and use them. Because in case of ORM, there's Hibernate engine, this is us, and we clearly say that, okay, yes, the object is stupid, the object doesn't have anything, it's just a data structure, and here's the engine. We just clearly admit that we did it wrong. Here, we kind of look like, you know, we did it right, so now they stay together. So now when you talk to me, when you talk to the object, then you don't see the database. But if you look closer, you understand that the object is still, you know, a data structure. It's still a primitive data container with attributes. But the way these attributes are used, the usage is coming from the parent class. It makes things even more complicated, in my opinion. And the SQL is not visible here. So we don't know, again, the same problem with the power of the database. Again, we rely on somebody who will use us as just a data container and somehow will put this data into the database. So I think my take on this pattern is that it's even worse.